How alone are we in our galaxy? Crickets, Cefax. Crickets. Yep, we're mostly alone out here. But are there other civilizations lurking somewhere out there in the depths of the Milky Way? Could they possibly have evil intentions and be a threat to us? Like we need more threats. Well, hey, let's have some fun with this. Some theorists reviewed humans' history and past actions towards one another. No miscongeniality awards there, and assuming they were somehow like us, used this to calculate the probability of space invaders. They determined that there could be 4 evil civilizations in our galaxy. The 4 could be eager for intergalactic domination, or maybe just for a good game of dominoes. They could be highly advanced in technology, or they've only just invented an evil version of game consoles. To understand how advanced these cultures could be, and what to expect, there is a way to define their threat levels. A method called the Kardashev scale analyzes intergalactic nations' possible abilities. With 3 different levels, it reviews the amount of energy a civilization could take from their star, indicating their tech level. This only includes those that have reached interstellar communication. So any other beings out there, using, let's say, space pigeons, will of course be excluded. Type 1 shows that they can harness the energy from the sun, but only from what is received within their own planet, like solar power panels. Type 2 is where they can use the energy directly from the sun, like through a Dyson sphere. It is used to harness all of the sun's energy, having been built entirely around it. And lastly, Type 3, where civilization can use all elements provided by the galaxy, with the power not only to harness the energy from stars, but also black holes, even the central supermassive one. These levels are important to assess how advanced civilizations could be out there. The Milky Way is estimated to be around 13.6 billion years old. Modern humans have only been around for the last 200,000 years, and we're only at Type 1. It's scary to imagine the time other beings have had to develop. We're considered a bit of a late bloomer in comparison. Earth is, shall we say, late to the party because we're located on the outer arms of the galaxy. Mathematicians posit that more centralized star systems have had more time to progress. With that in mind, how common would other intelligent beings be in the galaxy? With all the life-ending events Earth has survived, it's a miracle to have a planet like ours, and that we would be unique. Or are we? There are 100 trillion stars in our galaxy, and there are up to 200 billion planets, with an estimated 300,000 exoplanets capable of sustaining the kind of life we know about. From those habitable planets, how could we tell which ones have other beings eager to send us an email? No one's had the time to individually count. Of course, the Drake equation can give us some rough numbers if we take averages of a few key factors. It breaks down the criteria of how many planets with life are intelligent enough to make communication. The numbers are huge, considering how many stars might have planets. And from there, we distill it down further to those within the habitable zone in the solar system. This zone is called the Goldilocks zone, as it's not too far from the sun and not too close to it. It's just right. We reduce the numbers even further by calculating which of those habitable planets will then be able to support life. And from those random places, the equation takes the probability of how many intelligent beings will be, and if they are intelligent enough to communicate. The criteria are complicated, and so it's not an easy equation to explain, but from its estimate, there could be up to 100 million planets with intelligent civilizations. But just like with Earth's history or struggles, these civilizations may also have their challenges. World-ending events should be thrown into the equation, like asteroids, solar flares, supervolcanoes, and supernova. They could also destroy themselves through technology, like AI dominance or nanotech, or by affecting their own ecosystems and running out of resources, or by just acting stupidly. If we take these into the equation, the remaining living civilizations could be around 15,000. But what could they possibly want from humans? We do have an abundance of rare Earth materials that could be of value. ready to be harvested and easily collected. Besides an appealing vast amount of water they could suck dry. Hydrogen is a required element for rocket fuels, though these things aren't exactly rare in the galaxy and could be harvested easier from other, closer solar systems or asteroids. Our technology might be intriguing to them. Our range of innovations on Earth, invented while being isolated in separate countries, help provide different technology paths around the world. Other civilizations could have followed a completely different route and didn't learn the importance of many things we have on Earth, like karaoke. The same goes for applied sciences, where they may have evolved in different atmospheres with different elements. Their science would be mainly affected by that, and ours would provide them with more knowledge. Then there's one of the rarest things in the galaxy, that Earth can support life. This would be very useful for an intergalactic traveler, rather than going through the long process of terraforming an unlivable planet. Why not just take it? With a cozy outpost, it would be a lovely little holiday destination when they need some time off from conquering other civilizations. Fortunately, they wouldn't be interested in eating us, or probably wouldn't have an appetite for anything on Earth. They would need to have similar biochemistry and require the same enzymes to process the molecules we're built from. Phew! But the most likely thing they would want is to remove any competition. The biggest threat to them is anything that would provide a challenge to their domination. But before you get too frightened by these evil civilizations, this was based on human behavior. It's possible that any beings out there could lack or avoid many of our human emotions. For instance, their capacity for anger might be limited, or they could have evolved without it. They could come from a world with a history so different from ours that they could be overly trusting, making us the bad guys. But again, they may also lack empathy and other positive traits we have. Well, let's hope they only have our nice traits. Luckily, there's a big thing that separates us from everything else. The galaxy is huge, and it takes a very long time to go anywhere, even to our closest solar systems. The fastest thing we've sent into space is the Galileo probe, which travels up to 100,000 km/h. Even so, it would take 72,000 years to reach the closest star system, Alpha Centauri. Still, with a newly proposed laser-guided probe that can travel at 1/5 of the speed of light, it would yet take up to 20 years to make the journey. On a larger scale, the Milky Way is over 105,700 light years across. If a civilization was even capable of light speed, it would take them hundreds of thousands of years to travel from one end to the other. With a huge distance between the small number of civilizations, the only successful contact would be through advanced interstellar travel. But to achieve such a long journey, the greater the mass to be accelerated, the more energy is required, so it's not likely anything too large will be sent. But they could travel here very quickly in a small shuttle, using the ability to break cosmic speed laws. They may already be here watching us closely or just binge watching Netflix. They would need very advanced technology, and the number of species obtaining this is theorized to be only 2 out of the 15,000. This means there's a 0.01% chance of evil civilizations capable of visiting us soon. If they do know we're here, and they want something from us, it's likely to take them thousands, if not millions of years to arrive. So we've got plenty of time to relax, and time for more bright side. It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your space copter. But however scared you might be, you still need to do your job. So, you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the fourth planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish red world. That's a good thing you're wearing a spacesuit. The place is freezing cold. The thermometer sewn into the sleeve of your suit shows 80 EF. Time to make your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered with fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down, then try to run several hundred feet. Ha! You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses approaching you. In reality, you'd better get back into your copter and fly away as fast as you can. That's one of Mars' infamous dust storms. They mostly occur during the summer in the southern hemisphere of the red planet. They can sometimes cover the entire planet, and you can see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon, you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other, even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once, there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head, wow. The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive, but the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason may be the red planet's crust, which is very different from Earth's. It's static. On our planet, the crust is made up of 15 to 20 moving tectonic plates. As plates move over hotspots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth. And the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. That's a Marsquake. But how can it happen if Mars doesn't have actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh, look, Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some other minerals. You can probably compare it with soft, rocky toothpaste. Mars' mantle is also much thinner than Earth's. It's just 800 to 1,900 miles thick. As for the planet's core, it's made mostly of iron, nickel, and sulfur, and is between 900 and 1,200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's really an enormous canyon, or rather, a canyon system that runs along Mars' equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge it could span the entire continental United States from the Pacific to the Atlantic Ocean. Let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona, but it's 10 times shorter and around 4 times less deep than the canyon on Mars. Some scientists think that Valle Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years, and the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars' moons. They're among the tiniest in the solar system. Phobos is the larger of the two. It orbits a mere 3,700 miles above the surface of Mars. There's no other known moon that travels closer to its mother planet. It whips around the red planet 3 times a day, while the second moon, Deimos, needs 30 hours to complete one orbit. Phobos is getting closer and closer to Mars, about 6 FT each 100 years. Within the next 50 million years, it'll either crash into the planet or break apart and form a ring. Happy but tired, you return to your spaceship. Tomorrow, you'll continue exploring the magnificent red planet. And who knows what discoveries are awaiting you. Are ready to test your knowledge? Of course you are! You'll get 1 point for each correct answer. Without further ado, here our salam you. The sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you will get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it will look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then, why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it far to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around the meteorite, they think it's super hot. This is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know? But don't meteorites fall to Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outer side catches fire, but that layer is blown off on impact as a result of landing on Earth. As you would probably guess when they land, the meteorites are lukewarm at most, but not hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on, first the sun and now the moon. Am I living in a lie? Ha ha ha. So, people look at the sky and see only the bright side of the moon. The reality is the sun shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets the sunshine similar to the Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity though. Let's imagine this. If there was a black hole as big as the sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If a star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? It's a myth, or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day, although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes an apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and perhaps not too far from a trampoline, but without the springiness and instability. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? Fact. Quakes happen on the moon too, and they are called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, 55 Cancri E, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the sun. Do you think this is a myth or a fact? This is a fact. Although the sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails. Myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? I know it was too easy. This is a fact. Space doesn't have an atmosphere, so there is no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the sun. So this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the sun. But the distance from the sun isn't what defines the temperature. The heat depends on the atmosphere. So, Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the sun. The planet's distance from the sun affects the duration of one rotation. It's too close to the sun, and the sun has a strong, noticeable pull on the planets. Footprints on the moon can stay there for millions of years. Do you think this is a fact or a myth? Fact-checked. The moon has no atmosphere, so there is no wind blowing. Without the wind, there is no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments. Earth. The third rock from the sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creature to breathe. The weather here is also perfect for life to exist, unlike in places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles thick. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbit path, minding its own business, revolving around the sun until BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. So, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow, but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot. I mean, really hot. Even though it's not the closest planet to the sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and the sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the moon, just hanging out like a fly in the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in a dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries, in general, will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone will need to move towards higher grounds to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more. The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join their party. So what if Jupiter decided to turn up? Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter was the size of a basketball. It also has the largest storm we can perceive. It's known as the Red Spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. By the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It will rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We will all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will block us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each and break like eggs, like a big space omelet. Don't forget the moons crashing and breaking in the mix, but we'll already be far, far away by then, hopefully. Did you know that there's an astronomical object in which space and time actually swap places? How does it work? And what exactly does swapping space and time mean? Well, let's figure it out. Imagine that you're on a spacecraft. The vehicle can only move straight. Your path leads to some inevitable point, and you have no idea what lies ahead. You can only hope that it won't be too bad. Meanwhile, everything around you is complete madness. A chaotic collage of many historical events. What do you see? Ancient humans and dinosaurs. The birth of the universe? Future? Who knows? That's what the universe would look like if we swapped time and space. And theoretically, this is what you'd see if you fell into a black hole and somehow were able to survive. But how is something like this even possible? First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet. The circle of light is growing. It gets bigger and bigger in size until finally it turns into a huge circle. In real life, the bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we captured the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone. And time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She literally can influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is massive. Very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet, and with it, it also attracts our arrow of time. That means it slows the time down, and the closer the light cone is to us, the more the arrow bends, and the slower time goes. What does it mean? For example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity, right? But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend towards the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it got so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards? What kind of nonsense is that, you may ask? It will be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole, and there's an observer in a spaceship who watches you doing this for some reason. At first for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything is okay. But for the observer, first of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling. All because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then, you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer, even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now, the center of the black hole is your future. It isn't a place. It's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. Because now it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did, because in space, you can now only move forward as if along a straight line, and time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. You go first. Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer, though, they'll tell you that a comet is a large object made of dust and ice that orbits the sun. Arguably, one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And, most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1Pi Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these three occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the Sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the Sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Shiqi and Wenxian Tungkao chronicles, but another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910. One day after Halley's had emerged from behind the far side of the sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's Comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets in general may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids, though. Unlike asteroids, which are small, rocky space bodies also orbiting the sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before, that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelli was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's comet appears to have formed in the Oort cloud at the outer edges of the solar system, but Borrelli is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs.